Okay, it's 9 o'clock, Friday morning. Welcome to all you diehards, especially after Thursday night, but I appreciate you showing up anyway. My name is Brent Rector. I'm a program manager at Microsoft. I work on basically the Windows Runtime team. We're called Developer Runtime Tools, but we invented the Windows Runtime a number of years back. I talked to you, if you were there, in Anaheim when we introduced it. The Universal Windows Platform, which you've heard a lot about this week, is really sort of the evolution. I like to call it WinRT++, but marketing doesn't agree. So this talk is specifically oriented, it's going to be a little different than what you've seen to date, I think. I'm going to explain why we've made some decisions, run you through the thinking, where we're at today, where we're planning on going. And a lot of times the question comes up, you know, we said this is a universal platform. Can I really write an app that runs on everything? You know, do you really have all the APIs everywhere? And if you don't, what can you do about it? And it's a fair question. You know, in the past, writing to a universal platform, for whatever the definition happens to be for universal of that platform, sort of meant writing to a least common denominator set of APIs. I don't believe that's true for the Universal Windows Platform. It is and it isn't, you know, it's programming, and I'm an attorney in my spare time, so I can finesse anything. But really, it's a universal platform. But we have sort of these escape hatches called API contracts and type checking, which is sort of like reflection, that lets you take advantage of APIs if they're optionally present, because there will be some. There's not many, as you'll find out. So API contracts, a name I made up. It kind of stuck because we couldn't come up with any better term, really. But it's literally, here are a set of APIs, and we promise if we say that set is available on a platform, it's always available. All the methods, completely implemented, same behavior. Or it's not there at all. We haven't really had that idea. You can think of it as a feature in the past. So we want you to learn about those, learn how to use them appropriately. I'm going to spend a lot of time running you through our thinking, how we got there, and convince you that checking for OS version and inferring that you can use something is just totally the wrong way to go, which is why the subtitle here, How I Learned to Stop Checking OS Versions and Love Feature Detection. API contracts are more or less equivalent to features in some sense. There was an alternative title that a friend of mine came up with. A Bellevue soccer mom learned this one weird trick to avoid crashing on down-level Windows. I kind of like that title better. That didn't make it past review, but I got it in anyway. For those of you that saw that title, I tweeted it a couple of times and came. This is the same talk. This is just the more approved version of the title. We'd love you to submit an evaluation session after every talk. I'm sure you've seen this before. Here's the code you can scan to get that. So first off, let's talk about what I'm not going to talk about, which sort of sounds oxymoronish. We're talking about adaptive applications in this talk mostly. You're writing an application that adapts to the device you're running on. That could be a phone, that could be an Xbox, it could be an IoT device, it could be desktop, it could be a lot of things. But adaptive is only slightly less overloaded, I think, than the word object. There are a lot of ways you could be adaptive. So I wanted to define a couple of them, 3 actually. Version adaptive. You wrote your app to run on Windows 10, and then Windows 10.0.573.8 comes out, whatever the heck that is. Does it run on that? Yes, should. If it doesn't, we screwed up. But can it take advantage of things that were newly added in that later version of Windows 10? That's kind of like version adaptive. In the old days, we'd say, oh, you ran on 8, but on 8.1 you light up. On 10.1 you light up, whatever. So you can run on a base OS, but you can use up-level APIs. That's sort of your traditional light-up application, the way people think of it historically, because we haven't really had cross-device light-up. But that's the second family of adaptive type of apps. You're running on a desktop, but you can also run on a phone. You're a universal API, or a universal app, talks to the universal APIs. But the phone happens, for some release, to have a feature that you'd really like to use. That feature is not yet on desktop. As we'll see, I'll never say, at least if I do, I screwed up. I'll never say, this API is unique to this device, that we have device-specific APIs. Conceptually, we do not anymore. We have APIs that may only be on one device today, and I'll repeat this. There'll be a test later, by the way, on this particular topic. But we have an API that may be on the phone today because it hasn't got to Windows yet. That comes out 3 months later, or 6 months later, or maybe never, or maybe it comes out on desktop first. Regardless, if I'm running on a device and there is a feature, an API that's available on that device, I'd like to use it, even if that API is not available on another device. We call them device families because mobile's sort of a family of devices. It's not really just my Lumia 1020 or 830 or whatever that I happen to be using today. And then there's UI adaptive. And this is the one I'm not going to talk about at all. One, because I'd be the terrible person to talk about that. I'm not a UI guy, I'm a systems guy. And we've had a lot of talks this week from the XAML folks talking about how to do adaptive UI or responsive UIs, dynamic layout, that kind of stuff. So this talk does not concentrate on that. And in fact, when we get to my demo later, it deliberately does not try to do dynamic layout because I don't care about that. That's not the focus of my talk. I want to show you how to take advantage of APIs that may or may not be conditionally present. And I never care what device I'm running on. The app has no concept of that. So that's what we're talking about. I think this is kind of obvious, but for completeness, because I'm sort of a pedantic and I've been teaching for decades, I had to put it in here. Why would you want to build one of these? They're a little more complex, as you'll see, not very. We've done a great job about making them not be very complex, but why would you build an adaptive app? Well, it really increases your market share, or at least your potential market share. You have this tension, really, as we introduce new operating system versions, new features. Does your app use those and now has a dependency on the latest and greatest, which in the past, at least historically, has had a smaller market share because it's brand new. Not too many people have moved to it. Or do you target something like XP and you can't move on for 20 years? Bad idea, but we've not been able to convince a lot of people of that today. But with this new universal thing, I think you'll find that what you do want to do is, yeah, I want to use the latest and greatest features if possible, and we make it really easy for you to do it if possible, if it's on the platform. And then if you don't absolutely need them, your app runs on the other platforms as well that may not have them. So writing a version adaptive app really gives you, I can use the latest features, but I don't need them necessarily. Therefore, I have the broad market share of all the Windows 10 devices out. And as you've heard, Windows 8, 8.1 devices will get an upgrade to Windows 10. So we expect that to be quite large from a potential market share point of view. And then device adaptives. Why would you build a device adaptive? Well, again, it's the same idea. If you can build for phone and Windows, or technically desktop and phone is one target, you just build a universal app, you have a bigger market share, potentially. People have to like your app. Now, We want you to do this. I mean, clearly we would like you to build Windows apps that run as many Windows devices as possible. So the challenge for me, my team, Microsoft as a whole, is to make this as easy as possible for you to do. That's not really been traditionally true when writing these kind of apps. Again, I mentioned the least common denominator. I personally think least common denominator approaches suck. You end up with a bad app, just sort of the worst of everything. I have reasons for that I won't go into, but if you want to talk to me afterwards, I'm happy to share some experiences over my career. One of the ways that we want to make this easy for you to write an app that'll run across all devices is give you the same API. This is this universal Windows app platform that we've been talking about. If we can give you nearly the same API, to the extent we can do it, an identical API, not 100%, but as you'll see, not far off, that's great. You don't have to worry about, is this API present? Is Cortana present on this device? It is or it isn't, depending whether it's in the Universal API, which it is. And so you can just use it on anything, a HoloLens, a phone, a desktop, IoT device. But some cases there aren't, and that's what the focus of my talk will be. Well, how do you address the cases where they're not? So you'll find that it's not very limiting. The least common denominator is so large that you're not going to hit in the limitations very often at all. And then when you do, it's really easy to work around it. So sort of a summary, we want you to write these kind of universal apps. In fact, we want you to write universal apps in general, and then if you need to be adaptive to take advantage of some special feature that's on these kind of devices but not that one, make it dirt simple to do that. So what did you have to do in the past? Let's just step back a little. C++, load library, get proc address, load a DLL, see if the DLL's on the system. If the DLL's on the system, ask for the entry point address, have a function prototype of the function. Screw that up, you mess up your stack frame and crash. It wasn't very pleasant. COM, I thought, was a lot easier. But I'm a COM guy. Co-create instance query interface naturally lets you dynamically discover functionality. .NET, you had dynamic, the dynamic keyword. You had system.object, and VB especially, you could say o.abort, and we would determine at runtime whether there was an abort method. That wasn't that great in a way because you got no static typing. O dot, what methods are available? It doesn't say abort. You just would type in a word and you'd see at runtime whether it was there or not on the actual object. JavaScript actually is very naturally a language that looks, it's very dynamic and lets you discover if things are there. You can test for namespaces and methods and objects and types to the extent JavaScript has types is it undefined or not. So these were the traditional adaptive approaches, different kind of for every language, easier or harder depending on what you were focusing on. The pro, I tried to look for pros. I always like to start with the positives here. Spend a lot of time reading docs, and you actually get to call it work. So that's the only pro I could really come up with for that. But cons, there's a lot of cons. It's all runtime failures and hard to diagnose if you get it wrong, especially with load library, get proc address. That's pretty darn low level. The other con, and this is still true to some extent in the world I want to move you to through this talk, we have runtime failures. And especially if you're doing different light up per device, it only fails on this device. And so if you don't test in that platform, you won't see the failure. So that's kind of a con. We'll have to watch out for that. So now let's go back. I need to sort of take the blame for this slide and for this whole construct. But if you haven't done a lot of Windows runtime programming, You may not understand it. In fact, this was the best I could do to make it comprehensible at one glance. This tells you how bad it was to start with. When we invented the Windows runtime, and I was one of those people, we said, okay, we think about 20 years ahead, 30 years ahead. We're defining a new programming surface. And in this case, we were replacing Win32. Not replacing, but augmenting, because we didn't get rid of Win32. And we're going, okay, Win32's been around, well, if you count the Win16 years as well, 30 years. Anything we replace it with has to have a 30-year lifetime, so we better think about versioning. How are we going to version APIs? And that becomes very important when we're talking about light up. If you're running on Windows 10 and then you want 10.1, what if the API has changed? How do you know it's changed? So what we did in Windows 8 was we flagged every API with metadata that said what version of the OS this type, method, struct, interface, class was introduced in. Now in Windows 8, everything was introduced in Windows 8. And then we had a mechanism where if I had a class Brent and I wanted to add 3 methods in Windows 8.1, I could flag those 3 methods as new to class Brent in 8.1. And that's all in the metadata today, and tooling can help you out. And you're saying, I'm targeting 8, but I want to light up to 8.1. Tooling could help you and tell you, okay, this method you just called is only available on 8. You should really put some sort of check-in to don't call it unless you're running on, 8.1, don't call it unless you're running on 8.1. About the same time, the Windows Phone said, you know, we'd like to use the Windows runtime as well. It's a new programming model. It's got a lot of advantages. You can call it APIs in any language, not just C, really, which is what Win32 required. So Phone, we put the Windows runtime on there, and we looked at all the Windows runtime types. There were about 8,000 methods, members, classes, et cetera, about that time. Some of them didn't make sense for Phone. We weren't in the right mindset yet, arguably. So we flagged every type saying, when was this introduced on Phone? Might have been introduced in desktop Windows in Windows 8, but not on Phone till 8.1. Or there's a Windows 8 type that was introduced in Windows 8 Phone, but they're 2 different things. Just because they're both called Windows 8, there's Windows 8 Desktop, there's Windows 8 Phone. Bottom line, we got where here's one enum, the known folders enum, that tells you where the folder is for your music library, for your documents, etc. Look at that bottom line of code, save pictures. What platform is that available on? I write that line of code. What dependency on what OS do I pick up? I don't actually know because I can never remember. I have to figure it out every time. So Save Pictures was introduced in Windows Desktop version 8.1. That's what the W8.1 means. But it was introduced prior to that on the phone, in Phone 8. So any app that has that line of code can run on Phone version 8, but not Windows version 8. And Phone 8.1 and Windows 8.1, because that's sort of the minimum version. It's there later on. This is sort of the good picture of it, because at the time we, and I'm admitting to, okay, this is where we were, we've changed since then. It was possible to have a runtime class on desktop, and then when Phone took it, they said, we don't really have the concept of these 3 or 4 methods. We're not going to take those 3 or 4 methods. But we have these other concepts, so let's add 2 or 3 other methods to the class. So we would have a runtime class called Brent with different methods on Phone or Windows. Or even worse, the same methods with different behavior. How the heck do I write an app that says new Brent, call a method, and runs across any kind of device with that kind of differences? So this is where we were, and I'm sort of being dramatic. It's not as horrible as everywhere. But there were places where it was as horrible as I described. So we said, this is not good. We want you to write a lot of universal apps. We want you to run on any device. This makes it really hard. So we should eliminate these differences. We brought the teams together. There's one operating systems group at Microsoft. We create one operating system really that runs on all these devices, specializations for each one. And we addressed these issues where classes were somewhat different. We basically called it convergence. And to the extent we've been able to in one release, we have made, if a class foo exists on a platform, it looks the same on all the other platforms. Ideally, there's one binary that implements it too, and that DLL is shared across all the platforms too. In some cases, we didn't get to that. There's two binaries implementing the same class. But you no longer have to deal with this kind of thing where the class looks a little bit differently depending on which version of which OS, and your code has to be sort of version aware to understand what happened. So realizing that we kind of were going down the wrong path with the versioning, and the reason I spent a lot of time on that is this is my fault personally. I invented that versioning scheme. It was great when we started with Windows. When I started with Windows, we weren't going to put WinRT on phone. We hadn't made that decision. And when we put it on phone, it was a separate OS, so it made sense to version it similarly, but in parallel. And then we realized it'd be better, really, if we just had one OS for everybody, you, us, and my versioning scheme kind of fell apart. Now, in my defense, I convinced a lot of people that was a good idea. So it's partially their fault, too, for agreeing with me. But I spent a lot of time thinking about this problem after I realized, damn, I'm in a big, deep hole, and the walls are collapsing. What can we do now? So what does it really mean to write a universal app? A universal app is portable. It can go to a lot of different things. What does it mean to be portable? And really, if you back off, it just means what are your requirements? What are your dependencies? If I depend on Cortana, our speech engine, and that's all I need, I can go to any device that has Cortana, ideally, with taking the rose-colored view and then figuring out the technical details. It's not the hardware architecture. I can take a source code base today in VS, and I can say build, and if it needs an ARM build or an x86 or x64, it does the right thing. So really, hardware architecture is not a function of your dependencies or your portability anymore. We can take the same code and generate multiple binaries and put them all in an AppX bundle, so it looks like one app even. And then we have things like JavaScript and .NET, which can run on all architectures anyway, just because they're the way they're constructed. And device characteristics, it used to be, they were sort of controlling. You had to have a phone to do SMS or to make a call. But those lines have blurred a lot over the last few years. You can get a tablet that has SMS. You can get the touch screen on desktops now. So even what previously you'd kind of think of was a device characteristic, oh, I'm targeting phone, you really meant, no, I wanted a touch screen. Or I'm targeting a phone because I want to send SMSs. Well, what if you have, the right equipment in your desktop? Or I'm targeting GPS and accelerometers. Well, what device does that mean? That doesn't really fall in a good category. So device characteristics aren't controlling anymore. They don't really control what your dependencies are. You really need to back off and say, what do I need? What does the app need to run? That's what I need. I don't care what the platform is. And where this really came to light in my head once, I drew this slide. I used to have an animated version of the Venn diagram, but I lost it and it was too hard to recreate. But we had, Xbox then adopted the Windows runtime. And I had the same versioning scheme. So you could say this API was on Xbox v2, but it was on phone v1, and it was on desktop v1. And people said, okay, how do I write an app that runs everywhere? What APIs are available to me? So with 2 releases of desktop, 2 releases of phone, and 2 releases of Xbox, there's the Venn diagram of the possible intersections of APIs. I think I counted them once and they were 27, but it's kind of hard to keep track of all the little intersections. That's a horrible story. It's just not scalable. And we're not going to stop at 2 versions. So we really didn't want to say, okay, we'll just do the old-fashioned least common denominator approach, target the intersection of the APIs available on the set of devices that I want to use, and therefore there's what I can use in my app. That's really not going to work. So all this was some history to say, this is where I was at mentally when I'm going, we need a new method. And I'm more saying the global we now. I take the blame for my individual decisions, but I try not to take the credit for the ones that I didn't make. But we want to be able to build for all architectures. Not a problem, VS does that. We want to write code that works on any device. Well, make all the APIs available on any device. That's easier to say than it is to do. And then have some mechanism when you can't do that. You can't make the API universal. It's a great goal. We want 100%. We'll never get to 100%. It's sort of an asymptotic approach. So make it really easy for the cases where they're not completely universal. So where are we at today? Well, on the ensure APIs are available. It's kind of ironically, my mind was the versioning handled the special cases because I believed there would always be some. A friend of mine, Matt Mary, is working on an effort to make sure there are no special cases. So we're sort of, in a way, he's working to totally cut out the value of my work. And my work is in case he can't get to 100%, which we know we can't. So together, they're very good. For Windows 10, right now our projection is 85% of all Windows runtime APIs will be identical on all platforms. They are converged. If you have class foo on these 2 platforms, it's the same class, same behavior, same methods, etc. Now, even better, 85 is surprisingly large to me. If you've ever tried to do this kind of thing, that's a great number, I think. It's really impressive. But it's brought down because, of that 15%, there are a lot of specialty APIs that maybe are unique to Xbox or phone or whatever. What about APIs real programs use? So we went to the store and we analyzed the top 1,000 programs, got the list of APIs that they used, and said, okay, how many of them are converged? And 96.2. So less than 5%, barely less than 5%, of the APIs used by the top 1,000 apps are not in the universal set. So where you need to do this adaptive behavior, where I'm spending this entire hour teaching you how to use, you're going to use 5% of the time on average. Of course, if I ran the numbers a little different ways, I'd probably find that a number of those apps were 100% universal APIs, and then some of them did some specialty API, and scanning's not universal. If it's a scanning app, it uses more APIs that aren't universal. But I'm always amazed. I know that you're sitting there stunned in silence because this is so impressive. This is the way I can't see you that much. But it's, this is a great achievement. This is V1. Matt will continue, and Matt's over there. Matt will continue devaluing my work and making the need for you to write adaptive code less and less necessary. And that's great. If he can put me out of business, then I'll find a new business. But let's talk a little bit. There are some subtleties. I don't want to make it's not all rose water and grapes. Don't know where that came from. Tantalus came to mind. Just because you have to distinguish, an API may be present on a platform. This is a subtlety here, and this is why you're really coming to a university class, because you got me. An API may be present, but it may not be 100% functional. So what does that mean? Well, think of printing. I have an API, the printer API has, get me the default printer. On Xbox, the printing APIs are all there, but the Xbox will never support, at least never for this release, will never support printers being attached to the Xbox and printing. So all the printing APIs are there, but when you start the flow of using it and you say, get me the default printer, it'll come back and say, there aren't any. Same thing it would do on a desktop if there was no printer plugged in, because conceptually there's no difference there. So I don't really, even though Xbox will always say, no, there's no printer, even if you plugged one in because it doesn't support them. The APIs are there, but we have designed in this new converged universal Windows platform world for systems where the API is there, but it really doesn't support it. It fails in a natural way for the API. And I don't mean failure in an exception. We have a rule that these kind of failures do not cause exceptions, which might take your app down. They fail gracefully by returning false or returning null or returning whatever the right thing is for the API to say, sorry, you wanted one of those, there aren't any here. So you don't actually write any different code when you're dealing with printers when your app is running on the Xbox. Your app will just never find a printer on the Xbox, just like it would on a desktop or an IoT device or whatever. And then if we do enable printers on an IoT device or an Xbox, your app will work because now it gets a printer. So this is the difference I wanted to make here between API is present and fully functional, and API is present and partially functional. It's really partially functional, but only in the sense that it's going to return some kind of status to say, sorry, there aren't any of those. And you'll deal with that naturally. Then there's the other class of API where the API is either present in the OS or it's not there at all. I don't want to make up one because I have examples coming up. So we talked about this. Another example is webcam. Get the webcam on a device, or get the webcams on a device. It'll just return null. But there are the cases where we didn't put the API on the device. It's not really universal yet. And this will happen over time as, say, Xbox comes up with a new input device. We usually support those on Windows eventually, but the API is going to show up on one device first, wherever it's natural. And you might want to write an app that takes advantage of that API, but doesn't depend on it. So it will still run on a device that doesn't have the API. What we really, really dislike is people that write code. Well, I shouldn't say people. I don't dislike people. I dislike this programming approach where you write some code and say, if platform equal phone, therefore there's a valid inference that these three APIs are available. That's not true in our universal world. It may be true in this release, but then all of a sudden you run on desktop that has those APIs, your app doesn't take advantage of them because it said, no, they're only available on phone. Or if version 10, assume this is available, else do something else. Now, we actually do not give you APIs to ask what the platform is and what the version is outside of some app telemetry things. But So we can make it harder for you to make those kind of inferences, but they're actually not required at all. We have this easy mechanism. This is a class that, it's my fault if you don't like this class. I designed this class. It's a pretty trivial class. It's kind of a reflection-based class. I can, and it's a WinRT class, so I can use this from any language. So I can basically ask the current operating system, is this type, is this class present, meaning known to this operating system? I can create one and use it. Are these methods present? Are this method of a particular overload present? A lot of these things you can sort of do in JavaScript, but not everything. For example, JavaScript you can't say is a method with this arity present. Arity meaning the number of parameters that it takes, specifically input parameters in the Windows runtime sense. So we have these WinRT methods. They're all accessible to JavaScript. So JavaScript code can say, is this particular overload present? Which is nice because in new versions of the OS, we may add a new method that's an overload of an existing one that takes additional methods. So you can see what's here. I think all of them, but the latter two, are pretty self-explanatory. Is API contract present? So what is an API contract? That's good timing because now I'm going to talk about those. Basically, an API contract is a named and versioned set of APIs. Think of it as a feature, but I couldn't use is feature present because feature is so nebulous, so I came up with an equally nebulous term. An API contract can contain types, it can contain interfaces, properties, methods, events, structs, enums, basically everything that would make up an API. So you could think of Cortana, as I said. I pick on Cortana a lot because I like the name and I like the girl in Halo. So other than that, you know, Windows networking just doesn't have the same ring to it. It's also atomic. When we say we implement an API contract, we guarantee that a given OS will implement all the methods in that contract, all the types, all the structs, all the enums, all the values, or none of them. It is not allowed, and we enforce this by policy and through engineering at Microsoft, it's not allowed for them to say, you know, Class A I like, but Class B, part of the same contract, I'm not going to implement. No, then you don't implement the contract. So at some point in your code, a lot of times you just want to say, oh, there's a brand new class, Brent. Go back. Is type present Brent? Great, Brent is present. I need the V1 version of it, so the idea that it's there or not is all I need to know. I can call the V1 methods. That's all you need to know. But if I need to say, is Brent there? Is Lisa there? Is Bob there? Is Jane there? Is, you know, Fu there? Because I want to use all of them. And they're all really related. They're all part of this feature. Well, I can find out what feature or API contract they're present at, and I can say, is API contract version 1 present? Yes, now I can use all of those types and not have to individually test and worry about a system that had 2 but not the 3rd that I needed. And then, of course, features evolve over time. I'm going to add a new type. Cortana V2 has some extra, you know, Master Chief option. So I want to use it. But I can only do it if V2 is implemented, which is what the last both of those let you pass in a version and say, I need this feature, this API contract, but I want all the stuff that was, know if all the stuff defined in version 2.1 was available. So as of Windows 10 threshold, all API, every WinRT API is part of an API contract. There is not an exception for a public API, which are the only ones you guys care about. We put everything in one or more, well, not one or more, in one API contract. Talked about the guarantees. Also, with this API that you just saw, the API information API, you can query at runtime to see if an API contract or a method or type is supported. And then later versions are always backwards compatible. So if you ask a system that has Brent contract version 3, do you support Brent 2? It'll say yes. Now, the nice thing is, generally speaking, you don't have to worry about API contracts. As I said, 96.2% of all the APIs called by the top 1,000 store apps are universal. You don't have to ask if they're there, you can just use them. Now, if you need those extra ones, a lot of times is type present is good enough. I really just want to call this method on this type. I can ask if it's present. If it is, great, that's all I need. API contracts are more like, oh, I need this large area of functionality. I'll pick on Cortana again. And if Cortana is available. Now, it turns out that's a really bad example because Cortana is in the universal set. So you don't actually have to check for it. So you don't really need to know about API contracts until you have to. So here is an example of adaptive or light up code. Now, there is a subtlety here. I wonder if anybody catches it. The key thing that makes what we've done to support API contracts is this. This is .NET code, and I'm using a .NET or a Windows runtime type, actually, in this case, an imaginary one, by the way. I think I forgot to put hypothetical API. I'm not announcing any new APIs. But I now have static references to a type. So this HTTP client 2 imaginary type doesn't exist on a Windows 10 system. Let's say it came in Windows 10.1 or 10.2. In .NET today meaning prior to Windows 10, I couldn't even compile this. I couldn't JIT this code. The JIT would throw a missing method or missing type exception because when you went to the metadata on the system, it'd say, but I never heard of that type. It doesn't really care that you have it in an if statement. And the only way you could avoid this in the old days, meaning before Windows 10, is you could declare a variable of type system.object, and you could use method infos and reflections, or you could put all the strongly typed code in a different assembly and determine whether you do a load assembly and create a statically known interface to talk to that assembly, so that you don't bring in the types until you know you're on a system that supports them. It was a pain, and I'm being polite. But with the new tooling, with the new Visual Studio, with the new API contract support, basically you put an ifs check to say, okay, don't execute that code if it's not supported by the system, but otherwise I can just use all the static references just like it was an API always available. I think that's pretty cool. It took a hell of a lot of engineering to let me put up that one slide, but we accomplished it. And here's just a further example for another hypothetical where I at least remembered to put hypothetical. A game broadcast contract where I'm using a bunch of imaginary types that exist in that contract. Again, I do one check. I make sure I don't execute the code that actually references the types, and everything's good. All right. Sorry. Need a drink. So it's best now to define a couple of types, I'm too type-oriented here, a couple of terms. So we call a device family. A device family is something like mobile or Xbox or an IoT device, like HoloLens maybe. Well, that's not really an IoT device. It's its own kind of thing, really. But what is it from the point of view of this API contracts? It's an implementation of a set of those contracts. We used to call these platforms, which why the Universal Windows Platform is a device family. It's a family that implements all API contracts that are present universally. And yes, it's sort of a self-referential statement, but everything that's available on all platforms is part of the Universal Windows platform. And things like mobile and Xbox implement the Universal Windows platform plus some additional API contracts. Now, notice after the bold. These additional API contracts that mobile implements may or may not be unique to that platform. I have more slides to talk about that. It is completely incorrect to say or think, oh, the phone-specific API contract XYZ is blah, 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 blah. There's no such thing, at least conceptually. Pragmatically, I am on more shifty ground, but conceptually, the API contract XYZ currently only implemented on the phone platform is such and such. In the next 3 months, we could implement that contract on another platform. So you never really know from an API contract. It's an abstraction, just like the API. Here's a set of APIs. I can implement it on one device, 2 devices, 2 platforms, 3 platforms. No platforms is when I invented it. It's really correct to think of it as it may or may not be implemented on this platform yet. So that leads us to extension SDKs, and then I'll show you some code and example, bring this all home. What is a device family extension SDK? We have the mobile extension SDK. You'll see that in Visual Studio. Basically, an extension SDK is the metadata and tooling necessary for you to use API contracts that are unique. Again, I used the wrong word, that are available on a device in addition to the universal APIs that are available on all devices. So right now we have 3 or 4. We have the desktop extension SDK. And I have 2 or 3 slides here that show you the idea of the API contracts that are in this SDK. Now, the ones in blue are actually in other extension SDKs as well. So the blue ones are not universal, but they're part of different platforms, mobile and desktop, just to show you that there are such things. But you can see printer extensions, scanners, smart cards, media capture, playlists. We're going to come back to playlists in a second because I'm going to use that one. These are pretty niche areas. All the other APIs are universal. So this gives you an idea. And then here's the mobile extension SDK. It has some of the same one. IoT, the PPI, they each have just one. Most APIs are universal. There are only these little niche-y things that are not universal. So, before we run out of time, let me just show you the net result now that you have all the concepts. There we are. So I have this app that I wrote, wrote, whatever. It's sort of a Media Zune player app. My budget for licensing album art was $4.95 because that's all I had on me. So these are my pictures pretending to be album art. And we click on there, and now it's actually playing a song. But the key thing here is this Create Playlist button. I want to add this album to a playlist. It turns out playlist is one of the few things that aren't universal. It's only available on the desktop platform. So right now the button does nothing. So what I can do to turn that on is to uncomment out this code that talks about playlists. And then we will see when I compile, I get errors because right now I only am targeting the universal platform and the type playlist is not available in the universal platform. So I can go to References, and I can say, okay, I need the desktop. I know Playlist, because I can look in the docs and find out that the desktop extension SDK defines the API contract that contains playlists. And once I get this, the little squiggle should go away eventually. There it did. I compile. I run it again. Now, the playlist gets created in your music folder by default. So I click this button, and you see up in there in the little left, the playlist got created. So I've now, on a desktop app, I've created a playlist. Okay, and let's just change this and say, okay, well, I didn't mean to run it again. Let's change this to run on the phone. Now, think of what I've done right now. I've used an API that doesn't exist on the phone, the playlist APIs. I should have run this on the phone first and showed it to you, but it would have popped up the UI. Now deploy it again. Here we go. There we go. This is the same app running on the phone. Same code. I actually still have a reference to the playlist API, and if I click on the button to create it, I'm going to get an exception because I just called an API that's not present on this platform. So it actually makes a better demo because it showed the crash there. So let's figure out how to fix that. Well, that's pretty easy. We know that the playlist API is in an API contract. So I'll go up here and I'll say, okay, how about this variable here? Let's just capture, because when I run on a platform, an API is present or not, that's not going to change during the lifetime of the app. So I'll have a variable, are the playlist APIs available? And then I will use my contract check. A little overkill for this case because I'm only calling one method of playlist, but this would tell me if all methods are available on the playlist. And then I will go back here to the button click, and I just check that variable. I scrolled past it. And in fact, I should probably be a little smarter. And if we go up to the, we'll just hide the button if I'm not on if that API is not available. So there we go, we're on the phone. We click this. Where the button is gone now. I basically dynamically checked. No playlist support on this device. If I go back and I switch from running on the phone to the local machine, and let's delete the playlist that I created before. Create the playlist, and there it is back again. So now I've written a universal app. It's running on mobile. It's running on desktop. When it's on desktop, it uses the playlist API. Well, it doesn't ever check desktop. I fall into the same track. When it's running on a device that happens to have the playlist APIs, it uses them to support playlist in my app. There's nowhere in here that I check desktop or mobile or anything like that. So this is really universal apps targeting the universal Windows platform. If you need to step out of the bounds of the universal, that's how hard it is. I just spent an hour telling you about how to write one line of code, which I felt kind of bad about, but it's a really important line of code, and pretty soon Matt will make it impossible for no need for you to write that line of code, but you'll appreciate my work in the meantime. That's really all I have. Here's your session feedback scanning thing, and if there are any questions, I'd be glad to take them. And by the way, I will be upstairs. No, we are upstairs. I'll be over in the expert zone for the next hour after this talk. Feel free to come up and chat.
So are there any plans for either the Windows team, or I guess I don't know if it would be the .NET team, to release an official set of helper constants so we don't have to use strings in our application? Or is that going to be more of a community effort to say, hey, look, we're just going to generate these types to a NuGet package or something?
That's a great question. I think you're referring to where I had to have a string argument in the isPresent API, correct? Right now, the idea, my hope, and I'm not making any promises, that each language can provide support to do that. For example, I could say type of name dot full name in C# to get that string. But at the WinRT layer, which is what I'm showing you now, it'll stay strings. But we hope the language projections will put a more strongly typed, here this has to be a type name. We know what types are in this language. You can't really force it to be a type name at the Windows runtime level because JavaScript doesn't have the idea of type, and we have to project. But for the languages that have the idea of type, we want that to be strongly typed, and we're hoping tooling can help with that.
So, for example, the Cortana API you said is universal right now. Is that a guarantee that it's going to be universal in the future? Like if there are new device families that come out? Like I'm just wondering, if I write an app today and just assume that a universal API is going to be there, am I going to get burned in the future if, later we add, some even smaller, lower memory target gets added that doesn't support all the APIs?
Now, I rephrase the question, make sure I'm understanding. So we have this universal set of APIs today, but maybe there's a smaller memory target device type family that comes out. Would we ever take things out of the universal API?
That's right.
I hope not. It would not be very universal if we did that. I could imagine that certain APIs would not be fully functional in the sense that I defined. In that, okay, it doesn't support scanners, printers, or webcams on this device because it's a bracelet or something like that. And so they return null. So the APIs would be there. They would fall into the natural, not failure state, but not available state. But you wouldn't have to worry about them not being there.
Thanks.
Sure.
Hi, two issues with this. One that we're experiencing today with WinRT is reporting. With all of the other platforms that our apps run on, including the web, we can easily summarize what device is running by getting a user agent or the OS version. In WinRT, you have to use a workaround pulling up a web view to try and grab it's the only OS we work with where it's difficult to try and figure out what OS version it's actually running on. So that would be one request for reporting to address that. And I know, one issue with that when you go, forward with these API contracts and you've got these versioned in different things, they could be versioned independently, and so you've got that issue. The other thing I'd like to see, or I see potential problems over time, is the API you have just lets you check to see if a specific version is available. I'd like to see something where you could get an enumerable list of here are the API contracts and the versions that are there, because things change not just because of interface changes, they also change due to bugs. Like there could be a bug in something that's released by Microsoft that affects our app, and we want to, we need to mitigate that or notify the user, hey, you should go and update, you're experiencing this issue because of X, Y, or Z. And it would be really hard for us to check to see if a certain version is available if we have to explicitly query for it.
It's a great suggestion. I'll take it back to the team. With a little work, well, there are two aspects. To get the OS version, the add telemetry APIs, and I'm not sure what the name, Peter, do you remember the name of the API?
The API is analytics info.
Analytics info will give you, it's targeted for ad analytics that can say how many devices of this type is my app running on. We'll give you the platform version stuff. As to enumerating API contracts, we do not have an API that returns the set, but we actually do represent an API contract in the system metadata. So if you wrote any kind of reflection-like code that hit the WinRT metadata, you could walk through the metadata, and API contracts are actually a type in the runtime metadata. So by reflecting over the metadata, you can actually get the list of API contracts and versions currently on that system. Now, it would be a lot easier, your point, if we had an API that did that for you and just returned some kind of set, but which we don't have today, but it's good feedback I'll take back.
Cool, thank you.
Sure.
Are there any plans to offer universal APIs on Linux and OS through .NET Core?
Okay, question is, are there any plans to offer universal APIs on Linux or other OSs due to the .NET ports? I don't know of any. Doesn't mean that there aren't, because sadly I'm not looped into every actually gladly I'm not looped into every conversation at Microsoft. So I don't know of anything. That's all I could say. We have no more time. So I will be out at the expert booth. I'll be there for an hour. Feel free to come talk to me there.